The first, so we're in section, where are we at? 11.5 today. We're going to talk about volume of pyramids and cones. Well, let's recap what we've done so far. So our first shape, the first shapes that we talked about were prisms and cylinders. So for prisms, we said prisms were made up of, of polygons, sides that are polygons. We had two congruent parallel polygons as bases. And for all of our shapes, really, the base is the key. Our surface area. Surface area of a prism was HP plus 2B square units, where H is the height of the prism, and we found the height of the prism, the perpendicular distance between the two bases. P is the perimeter of the base. And B is the area of the base. So that was our surface area. And we said that cylinders were cousins, the curvy cousins of prisms. And our surface area, the formula was really the same, but because the bases are circles, the areas of the bases is 2 pi r squared. And the side of our cylinder was a rectangle, and one side of the rectangle was the circumference of the base. So that turned into 2 pi r h square units. And r is the radius of the base. So those were our first ones, guys. Then we talked about the volume. So for prisms, we had a nice, easy formula. The volume equals the area of the base times the height, cubic units. And this key still works for that. For cylinders, we had the exact same formula, but because the base is a circle, we could say the volume was, the area of the base is pi r squared h units cubed. But these formulas are exactly the same. Area of the base times the height. Area of the side plus 2 areas of the base. And then the last time we met, we talked about pyramids. Our surface area was the area of the sides. We added up all the areas of the sides. The sides were triangles, and then we added the area of the base to that. And when we came up with a nice formula that our surface area was 1/2 LP plus B. And here L is the slant height. And this would be square units. P is still the perimeter of the base. And we got this formula by adding up the sides, the areas of the sides, which are triangles, plus the area of the base. And then finally, cones, our surface area. The same formula. We're adding up the area of the side, which was the curved surface, and the base. So for a cone, we ended up with pi RL plus pi r squared, square units. And our surface area formulas all came from breaking up our shapes into nets and adding up the areas of all the nets. All right, we good so far? So this is everything that we've done in chapter 11 so far. All right, so let's talk about the volume now of pyramids and cones. But before we come up with a formula, I have a little demonstration that I want to show you. All right, here are 3 pyramids. The bases of my pyramids are all squares. And the heights of the 3 pyramids are all the same. These heights here, there's our heights there. And what I'm going to do is fold up these 3 pyramids to make another shape. Any ideas what that shape might turn out to be? So there, folded them up a little bit. Folded them up a little more. Looks like it might be a cube, right? So let's fold it up. So there they're coming together. And there's a cube. The volume of this cube is the area of the base, the square, times the height. But how many pyramids made up the cube? 3. And they all have the same base. They have the square as the base, and they have the same height. So it takes 3 pyramids to make up this cube. So how is the volume of one pyramid going to compare to the volume of the cube? 1/3. And it turns out that I can always do that with a prism. I can divide a prism into 3 pyramids, and the 3 pyramids will exactly make up the prism. So that's where our formula comes from. We can also, if we had hollow ones, we could fill up a pyramid with the same base and the height as a prism, and it would take 3 pyramids full of water to fill up the prism. So that's where our formula comes from. So the volume of any pyramid, and I'm saying any because it doesn't have to be a right pyramid here, because Cavalieri's principle works for our pyramids also. And remember, Cavalieri's principle was the one where I said we could make it slanty and it doesn't change the volume. Well, that works for pyramids also. So the volume of any pyramid, the volume is 1/3 the area of the base times the height, or you can write it as the area of the base times the height divided by 3. Those two things mean the same thing. We're going to have units cubed. B equals area of the base, just like before, and H is the height. Nice, easy formula. It takes 3 pyramids to make up a prism. All right, questions on our formula? Okay, let's look at an example. So here is just a reminder about drawing pyramids. This is how I like to draw them. Draw your little parallelogram that makes up the base. There's my vertex, and then just connect your vertex to each corner of your base. There's my pyramid. And we want to, for this one, find the volume of the square pyramid. And I need to put some dimensions in here. Let's say this is 18 yards, And I'll put this on here. And this is 15 yards. All right, so we know the volume is the area of the base times the height divided by 3, or 1/3 the area of the base times the height. What's the area of the base? 18 squared. This is a square pyramid, so the area of the base is 18 times 18. And that comes out to 18 times 18 is 324. That's going to be square yards. And the height. The height is 15? No? What is this? That's the slant height. Well, how do we find the height? Let's draw it in there. There's my height. There's that nice little right triangle that's inside my pyramid. There's H. How can I find the height? How long is this piece? 9. This goes right to the center, right? So that's 9 yards. So what do we do to find the height? 9 squared plus h squared. Yes? So we can say 9 squared plus h squared equals 15 squared. We have to use a Pythagorean theorem then. And this one turns out nice because we get 81 plus h squared equals 225. Subtract 81 from both sides. I get h squared equals 144. So h equals 12. So we found the height. 9, 12, 15 is another Pythagorean triple. Worked with another Pythagorean triple. Now we can plug in into our formula. The volume equals 324 times the height. 12 divided by 3. When I calculate that all out, I get 1,296 cubic yards. But don't forget about that nice right triangle in the middle of your pyramids and in the middle of your cones. All right, questions there? All right, let's talk about cones. And why don't I say this instead of just cones? I'm going to say the volume of any cone. Now when we came up with our formula for the surface area, we talked about cones. We said cones were the relative of pyramids. So based on what we just talked about for our volume, what do we guess the volume of our cone is going to be? Area of the base times the height. Exactly the same as for a pyramid. We can make up a prism, not a prism, a cylinder with 3 cones. And because a cone has what shape as a base? Circle. What's the area of the base? Pi r squared h divided by 3 cubic units. And you'll also see this written as 1/3 pi r squared h. 1/3 is the same as dividing by 3. exact same formula as the formula for a pyramid. And the area of our base is a circle. All right, questions there? Okay, let's look at an example. And notice we said any cone, so this works for oblique cones also. So I'm going to say for this example we want to find the volume of the oblique cone. And here's my cone. And I'm going to put the vertex a little over to one side there, and then draw my cone in. There's the side. And I'm going to say this is 16 centimeters. And this is 15 centimeters. All right, so the volume, area of the base times the height divided by 3, or pi r squared h divided by 3. So what's the radius of this thing? 8 centimeters. We have the diameter here. So we have pi times 8 squared. What's the height? 15. Height is from the vertex perpendicular to the base. So pi times 8 squared times 15 divided by 3. If I wanted my answer in terms of pi, I would square 8, get 64, multiply by 15, divide that number by 3, and I would get 320 pi cubic centimeters. And if I wanted it rounded to the 10th, I would multiply 320 by 3.14, and I would get that that's about 1,005.3 cubic centimeters. All right, questions there? Okay. There's that.